Hello everyone, Namaskar. Now we have entered in the last week, that is the module 12 of the course. In this 5 lectures of this module, we will discuss about various aspects of green technologies, byproducts and waste utilization. Okay. So, in today's lecture, we will discuss the green technology and near zero waste processing. Okay. The concept that we will cover include an overview of green technology, novel green processing and extraction techniques, near zero waste management and waste utilization in fruits and vegetable sector. So, what is the green technology or what is the goal of the green technology? I hope you all know green technology means it is the environment friendly technology. So, the aims or goals of this include the sustainability, that is the meeting the needs of the society without depleting the natural resources. Then another important goal is source reduction, that is reducing waste and pollution by changing patterns of production and consumption. Cradle to cradle design, creating products that can be fully reclaimed or reused. And then innovation, like developing alternative to technologies that damage health and environment. So, that is the one major aspect of the green technology that we should have, that is try to improve the traditional technologies etc., and make sure that these technologies do not have any adverse effect on the environment and the health of the public. Then finally, viability, which is a very another important aspect, that is the creating a center of economic activity around green technology like investment, career opportunities etc. Okay. So, the application of green technology in the food sector finally aims to reduce energy use, reduce environmental footprint, that is the particularly carbon footprint, reduce process induced toxins in the food, okay, reduce waste generation, that is the technology should be used in such a way that is minimum possible. We will see little later zero waste concept. Okay. Then alternatives and sustainable processes for analytical and processing purposes. So, these are the some of the aim and applications of the green technology. So, eco designing in food processing is a very important, that is a purpose of eco design is to prevent or design out adverse environmental impact throughout the life cycle of the product or service systems. As I told you that yes, every possible effort should be made to make sure that in the food value chain, starting from the primary production, processing, packaging and distribution, even in supply chain, consumption, storage etc., in all this there is ecological balance is maintained, that there is a proper integration of environmental consideration in the product development process. It is a consumption process in whole supply chain. That is how it is done, that is use of environmental friendly raw materials, efficient use of raw materials, cleaner production options, optimization of packaging, have proper packaging conditions so that the minimum waste or no waste is generated, then effective distribution system and then environmentally sound use of products, process, technology etc. So, by this means that is it is a end to end holistic approach should be used to make sure that either in the production, in the processing, in the consumption, in the utilization, that whatever we are doing, that it should be a environment friendly process. That okay. So, the novel green processing technologies, that is high pressure processing, pulse electric field, pulse light, ohmic heating, ultrasound processing, cold plasma treatment, membrane processing, microwave processing, ultraviolet treatment etc. These are the some of the technologies which are considered to be green technologies. because these technologies normally they aim to achieve food products which are rich in health promoted components with the appropriate shelf life, and they also fulfill the market requirement of garden fresh and natural like food products, and they play a crucial role in product innovation, product sophisticated and diverse food products. They produce sophisticated products. Okay. So, in earlier lecture, that is lecture 45, when we were discussing essential oils and oleoregens, pulse electric field, ultrasound processing, microwave treatment, etc., were discussed in details. So, other processes we will briefly discuss here, like pulse light processing. You can say the pulse light is based on application of short time light pulses with an intense broad spectrum, and these pulses are inactivating the microorganism at a surface level of the food and the packaging material. You see here, that is the air untreated sample, sample is passed through, and there is a xanthan flash lamp light, so that is pulse light. So it is treated, that is for a very few time it is exposed, that the commodity is exposed to this light, and then it goes out. So, microbial DNA absorbs ultraviolet light, which leads physicochemical changes in its structure, thus resulting in damage of genetic information, impaired replication and gene transcription, as well as eventual death of the cell. Pulse light treatment employs 1 to 20 flashes per second with an energy density ranging from 0.01 to 50 J per centimeter square at the surface, and it has potential application in the food processing requiring where a rapid disinfestation is aimed. Okay. Then ohmic heating, processing. Here again the food is being placed between two electrodes. Okay. The basic principle is that, and the electrical energy which is conducted through the food is converted into thermal energy due to the electrical resistance of the food, which is a phenomenon known as Joule effect, and it leads to volumetric and instantaneous heating of the product. Okay. When the product is placed between two electrodes and connected with a power supply. So, effectiveness of the process is strictly related to the ohmic heating rate to which power is being supplied, and it depends on the electric field and the electrical conductivity of the product. Cold plasma technology. It is a cold plasma is composed of positive and negative charged ions, electrons and charged particles, which are generated by an electric discharge of different gases such as argon, helium, nitrogen, oxygen and atmospheric air. So, the chemical species generated by the plasma discharging in air, okay, they promote the sanitizing technology in the field of food processing, where the inactivation effect against the pathogenic microorganisms. Okay. So, the benefits of green processing technology, that is, it eliminate the local use of boilers or steam generators, which invariably create lot of environmental problems. These green technologies avoid the use of non-renewable energy sources like fossil fuel, etc., are not used there. So, again carbon footprint is reduced. These are energy efficient, water savings and reduced emissions are there. They are environmental friendly technology. All these technologies which are in the earlier slide I listed, they are all considered to be environmental friendly technology. They maintain the integrity of the photochemicals and retain the nutritional quality of the fruits and vegetables. They inactivate oxidative enzymes and minimize browning, and there is a minimal impact on color, flavor, volatile aroma compounds, etc., in these processes. Then another aspect, that is emerging green extraction technology, which is important in the fruits and vegetable processing, particularly when we are discussing about zero waste management, etc., that we will come little later or even in the next class. Okay. So, what is the green extraction technique? It aims to increase the extraction yield, extraction quality, extract purity, etc., as well as the extraction time, amount of solvent required for extraction, energy consumption, environmental impact, economic cost, waste generated, etc., they are lower down in using green extraction technology. So, the properties of the recovered product, the product recovered or extracted using green technology, they have more natural nature, naturalness is there, they are safe, their quality, purity, functionality is all excellent. So, the various extraction techniques are green technology, green extraction technologies include supercritical fluid extraction, subcritical water extraction, pressurized liquids, microwave assisted extraction, ultrasound assisted extraction, enzyme assisted extraction, pulse electric field, etc. Even the various solvent which are used in together with combination with these technology, maybe water, supercritical fluids, then ionic liquids, deep eutectic or natural deep eutectic, okay, or even bio based solvents. So, even again in the lecture 45 we discussed majority most of these technologies, but some important one we will again summarize. The high pressure extraction, it is one of the very emerging environment friendly extraction technology that can destroy the cell walls, membranes and organelles of the plant tissue, which also enhance the mass transfer process. It increases the extraction efficiency, reduces extraction time and decreases solvent consumption. Currently, the range of pressure of industrial use is between 100 and 600 megapascal, which is of course determined by the processed product. What is the nature of the product? Okay. And in other words, the pressure transmission is uniform, it is instantaneous and adiabatic, which implies it can be applied regardless of food shape or size. Studies have examined the extraction of functional ingredients from the food wastes such as lycopene from the tomato paste, anthocyanin from the grape skin and corrugin from longan fruit pericarp and so on. So, using high pressure extraction technologies, you can see in the high pressure there is a pressure generator chamber, heating it is provided with heating and cooling. The sample is kept in this chamber and then it is compressed. So, when it is compressed, the basically cells etc. they are ruptured, they sometimes depending upon that accordingly the pressure is selected and it may give. Okay. Then electric field versus ultrasound assisted extraction, you see that is a freeze dried blueberry pomace is taken, it is subjected to either pulse electric field extraction or high voltage electric discharge method or ultrasound assisted extraction. So, in the ultrasound assisted extraction, that is this pomace, that is powder, it is put into some liquid solvent and this is whole is put inside the ultrasonic transducer and then it makes extraction efficiency, extraction increases, that is the principle of acoustic cavitation there, where there is a compression and refraction etc. the time and pressure and the extraction rate is efficient. In the case of HVED, that is high voltage electrical discharges, that is this commodity in that it is kept in the plate electrode or it may be needle electrode. Okay. So, here the fluctuation, that is HVAT, that is how it extraction pulse shapes, you can see here in this figure. In the PF, the voltage and versus time, the time increases, the voltage you are reducing, that is the pulse PF you are getting, that is in this plate electrodes are provided, in between these plate electrodes the material sample is kept. So, basically the mechanism of action in all these processes, it is basically irreversible electroporation. That is, when you are applying the electric field, then these cells etc. biological cells are damaged, ruptured, that is pores are created, either existing pores are enlarged or new pores are created and those through flux, that is the cellular components from inside they go outside, the outside solvent it goes penetrates inside the cell and there is release of polyphenolic components, dissolve the polyphenols etc. all right, or cellular material leakage, all those things are then you can get extract the component and the same with the here in the case of that ultrasound assisted also there is a successive propagation, that is bubble size increases, finally temperature and maximum pressure gives, then bubbles collapse and this again when the bubbles collapse then solvent can go in and then polyphenol compounds etc. can come out. So, these are the ways how that they facilitate the extraction. And high voltage electric discharge, okay. In this technique, energy is introduced directly into an aqueous solution through a plasma channel, which is formed by current of high voltage electrical discharge between two submerged electrodes. The intensity of the electric field is able to induce an avalanche of electrons that are responsible for starting the spread of the positive streamer for the negative electrode. So, secondary phenomena such as bubble cavitation, turbulence, pressure shock waves, etc., these contribute to the improvement of cell damage. They facilitate the release of compound and extraction of biomolecules from the cytoplasmic cell. So, it is again here there is shock waves that cause the damage of the cell. So, membrane suppression, I think earlier we discussed about membrane suppression also, that is the fruits or vegetable or whatever waste sample, it is given physical treatment like washing, drying, then you get extracted, and then extract is subjected to isolation and purification either using microfiltration, ultrafiltration, nanofiltration or reverse osmosis. These are the known technologies, and these what can pass through these membranes and what cannot pass through, it is given here. Generally the reverse osmosis if you use, then you can get it is can be used the concentration, that is only separation of water even from the fruits and vegetables, etc. That is the that biological water. Okay, high purity water can be, that is, so juices can be concentrated using these membranes, etc. Then membrane assisted solvent extraction techniques. See, that is it is the extraction vial. In this, that is there is a membrane bag, and this is put into the non-polar solvent inside the bag containing the sample, and then this is agitated, that is separated the corpus. So, this throughout the membrane, that is the material which is it comes out, the volume injection, that is easier separation of the polyphenolic compounds, etc. It can get the selective separation of the components. You can select the membranes accordingly. Then enzyme assisted extraction, okay, that is in this case it is again a known technology and used by the industry. Addition of an enzyme leads to enzymatic hydrolysis, which results in the faster cell wall breakage. Take food sample, fruits and vegetables, give subject to pre-treatment, obvious pre-treatment, and then you have a dry it, maybe in the form of powders or in the form of liquid, whatever may be, that one has to optimize the process parameter condition. Then it is subjected to enzyme hydrolysis treatment, where matrix cell wall is disrupted by the enzyme reaction. You can see here, that is the cell is disrupted. So, the disruption of the cell depending upon, and it may vary with the temperature, pressure, time and concentration, etc. And then there is a release of polyphenolic compounds or other such bioactives from the food matrix. Okay. So, that is filtered, that is removed or aqueous part, and then finally subjected to the purification treatments, etc. One can get concentrated polyphenolic extract or such other bioactive extract. And for total phenolic extraction, the enzymes which are generally used are, in the case of chokeberry pomace, it is a viscozyme L or cellulose XL. In grove pomace, cellulase, tannase, guava leaves, cellulase xylase, and citrus peels, it is viscozyme L. So, that is similarly there is a long list of enzymes depending upon the commodity, etc. one can use. Then a combined technology. It is another emerging hurdle technology concept, that is the use of various like a combination of ultrasound assisted enzymatic extraction, microwave assisted enzymatic extraction, ultrasound and microwave assisted extraction. These can be good. Then when you use 2 or 3 similar technologies, you can get that is the synergic effect. It minimizes the degradation and enhances the extraction rate, and you can get a better recovery. So, what is there here in the plant source, you can take either main the plant source or even the byproducts or waste products, etc. sample preparation, and then it is put weighed sample into the vessel. Okay, that is the extraction procedure, and add the extraction solvent. That is in the known amount of a weighed amount of the sample is kept into the vessel, and the solvent is added. And after the solvent is added, then you have a microwave system, you may have a ultrasound radiation system, then this solvent plus sample can be subjected to microwave treatment at GR conditions of microwave power and other things, or it can be ultrasonicated. Okay. And these both microwave treatment, radiation treatment, ultrasound radiation treatment, they can be sequential or they may be simultaneous. There are also equipments available where in the same facility you can do both. Okay. So, simultaneous, and finally, after it has been means solvent is added, then microwaved, then ultrasound treatment are together, then finally the enzymes, required enzymes are added and give the reaction time. Finally, turn off the system and allow it to cool down, clean up the procedure, and post treatment like recovery, purification, etc. you can get this. So, this is a combined technology for the extraction. It is always considered to be a better technology. Okay. It uses reduces the number of stages, the extraction time, and the energy consumption. Okay. So, now near zero waste processing after the green technology concept. So, this near zero waste management, what is that? So, you have the food processing waste, lot of food processing waste, particularly in the fruits and vegetable industry, lot of waste is generated. Okay. So, there should be that these wastes should be collected and it should be segregated into the like solid waste and liquid waste. So, solid waste, then again it may be non-biodegradable waste or organic waste. Non-biodegradable waste can be recycled or used in making building materials, etc. or such, whereas the organic waste can be subjected to various processes which we discussed earlier, like enzymatic treatment, supercritical fluid extraction, microwave extraction of bioactive compounds, etc. You can get bioactives, and the remaining you can be used as a compost, or it may be again fibers, etc. Whereas the liquid waste can be subjected to anaerobic treatment. After that, it may be membrane processing, okay, and then ozonization, etc. Okay. It can be sanitized, it can be used, that is the fermentation, various products can be made, or even the compost after this filtration, etc. The residue can be compost. So, this can be recycled. So, there are a specific process, but only the most important thing here is that there has to be a good mechanism in place, management in place, that is for the collection of these waste material. First thing, use appropriate technology or green technologies which reduces the waste generation, and whatever another after that whatever waste is generated, that should be properly collected and that should be the reused or recycled in a proper manner, as we discussed. So, we will discuss a few little more like waste management, okay, that you get that first thing, that the processing facility, etc. or first you assess that assessment of the waste resources, that like supply in the pre or post harvest, in the processing stage, or wholesaler, retailer, food service point. So, the various in the supply chain, in the various stages, what are those stages where the waste is being generated. Okay. All right. Then have a proper management, okay, have the proper resource, proper collection system in place, okay, and it should be cost to process waste, economics, etc. should be taken. Then it should be given utilization, that is proper effective wage, like we told in the earlier slide. It should be properly utilized, and but sometimes important thing is that where these waste material, when they are being utilized, the technology or process which is being done, it should be that is, it should be a public should accept it. It's like, so accordingly communication campaign or education of the public is very essential. Okay. Even public participation, that is not only public should accept, but public should participate in that, because even in the kitchen, in the fruit and vegetable, there are lot of waste generated in daily basis. So, a proper collection mechanism, and we should encourage that as the people participate in that, and that can be collected and used in a very many value added product. Even the government also should encourage in this by having a proper framework, legislation framework, health and family standards, financial viability, support them financially, all these measures, etc. So, these waste can be utilized for biorefineries, bioethanol production, lignocellulosic biofuel, natural fibers in concrete, thermal and acoustic insulators, etc. So, all these things, various things can be done, okay, even from the food and vegetable processing industry waste or even kitchen industry waste, etc. The merest of waste utilization waste, that is higher cost of unprocessed waste disposal, potential source of reusable energy, potential raw ingredient for commercial fermentation technologies. Okay. These are the possible commercial products derived from the food supply chain waste, particularly from the plant derived waste material, that is whatever material they are subject to extraction and processing technology, and various molecules like lipids, hemicellulose, bioactives, protein, starch, photochemical phenol, etc. can be made, or by incineration you can get fly ash and hydrogels, or pre-treatment and hydrolysis one can get sugars, fermentation, that is products like bioethanol, butanol, enzyme, or even anaerobic digestion. It can be used heat, power, biofertilizer, etc. So, these are the some of the many commercial value products can be obtained from these waste. Okay. So, waste product utilization, if we concentrate mainly on the fruits and vegetable processing. So, after the processing of the fruits and vegetables, the generally what are the different waste? This may be pomace or oil cake, peels, stalks, seeds, stones, all those things, and they all these waste are rich in fibers, phytochemicals, polyphenol, flavonoids, organic acids, vitamin, minerals, and they have a good antioxidant property, antimicrobial, anti-cancer, anti-cardiovascular, antioxidant, or they also have the immune modulatory effect. So, all these wastes they should be properly processed, okay, and good either in the powder form or in the liquid form they can be used, that is extracts or powders. They can be used as an ingredient either as a nutraceutical or in functional foods. They can be used in food fortification program. They can be used as a natural preservatives, biopigments making that biological color, okay, biocolor, food grade color, edible oils, chemical industries, animal feed industries, biofuel. So, lot of products potential applications are there of these wastes. Okay. So, here in this I have given that exploitation of food and vegetable industry or supply chain waste for high value products, that is the reprocessing of fruits and vegetable waste, that is waste. As I told you that there should be proper collection mechanism in place force, and these waste, that is they should be properly processed, like for example, the byproduct of waste from sweet potato, banana skin, orange peel, mango waste, pineapple peel, they can be used for getting single cell protein. Pineapple waste, banana waste, even bioethanol production. Similarly, banana peel you can get fiber, orange peel can be processed for proteases, enzymes, etc. Potato peel can be processed for xanthan extraction. Even guava, pomegranate and pineapple waste they can be used for phenolic extraction. Apple pomace, they are good source of polyphenols and antioxidants, they can be extracted. Tomato waste, that is in the tomato ketchup industry, juice processing industry, after that seeds, skin, etc. they have good source of lycopene, that is the lycopene can be extracted from pomace, or carotenoids can be extracted from skin, etc. Okay. Similarly, there is the fruits and vegetables, they can also be exploited for making packaging materials, like that is the you take the peels, skin, leaf, kernel, pomace, etc. That is after the bioactive extraction, the residue which is getting, they can be used for renewable and biodegradable biopolymers, composite film of good stability and barrier properties. Even they can be used to make active barrier or film or antioxidant, antimicrobial compounds, etc. Even now in India is also some institutions they have worked on that is the edible packaging material from that this jackfruit leather and things, okay, jackfruit rind, etc. So, there are various examples of this. Then the case study, you see that waste utilization in fruits and vegetable sector, that is spray dried powder of peanut skin, that is peanut skin, it is powder, hulls it was mixed with the sugar syrup, and this was peanut snack bar was coated with the syrup solution. The syrup solution which is mixed with the peanut skin powder, and it was found that antioxidant content of that snack bar increased, bitterness and astringency was reduced, and aroma was improved. Similarly, mango processing industries, that is the wastes were peel and the kernel, they are used for the fortification of their powders and cookies. Okay, that even mango peel powder or mango kernel powder. Mango kernel powder is used for even mango kernel has very good quality butter, very good quality triglycerides that can be extracted and used as a good substitute in the confectionery industry and other. So, it is used for enhancing the nutritional quality or textural and sensory properties, of course, are not affected. Then utilization of apple processing waste, similarly, that is various, like what we discussed, that bioethanol for pectin production, for fiber concentration, for hemicellulose, etc., or for oligosaccharide, cellulose production, phenolic extract, because in the apple, again apple juice processing industry, lot of almost about 50%, even in the citrus juice processing industry, almost about 50% to 60% goes after the juice extraction. Can you imagine from the citrus fruits, after the juice extraction, around the whatever going waste is almost 50 to 60% to the tune of that. Okay. So, that and that is all having a very valuable components. So, this can be generalized and used very high value products. Okay. These are the utilization of grape processing waste, like pomace can be used for antioxidant and antimicrobial production. And it can be incorporated in cereal production to increase phenol content, that is grape pomace. Then grape seeds, the oil in the grape seed is very rich in tocopherol and tannins. It is used to replace animal fat in products like sausages, etc. Then grape peel, they are again rich in resveratrol, polyphenol, tartaric acid, etc. And they can be incorporated with tea leaves to increase the phenol content. They are used in natural antioxidant in oil, and you could see that winery industry, how much they produce, wine making industry, the grape by waste and byproduct. So, all these things can be properly channelized in making, and there are procedures, there are technologies available for all these, whatever we are telling that I am mentioning here, all these things, technologies are there. Only thing, one has to have a proper mechanism in place, machinery in place. So, finally, I will say that yes, these zero waste management is an emerging concept, that is if we use that, whatever our efforts should be, that one thing, that is by eco friendly design processing aspect, that is just first thing that we should make sure, or all the industries should make sure, ensure that there is minimum wastage. Okay. Even all the components are processing line, if the required be, that even the processing line, processing technology can be suitably tailor made, that each and every stage the material should be properly collected. And means, like when you are making the juice, then after washing and when expressing, the peel should be collected. Even the tomato juice make in such a way that the seeds, after that is the seed in the tomato, that can be used even for germination purposes and other purposes properly, whether this tomato is handled properly before the extraction of the juice. So, all this accordingly the existing technologies are there, it can be. So, one can get number one, you will get that environmental pollution can be controlled, carbon footprint can be minimized, okay, and at the same time more revenues, returns, that is these waste utilization, they will provide good industry input, economics value to the producers, marketer, and then. So, zero discharge waste management aims we should have, our efforts should be, so not only to produce minimum waste, but also to utilize them in an effective way, so that we can offer maximum value to the consumer, to the producer, to the everybody. So, this is all, these are the references used in this lecture. Okay. Thank you very much for your